Hope everyone had a good lunch, and we'll try to keep this entertaining enough so you don't fall asleep after lunch. But this is the golden thread in action from EdPlus Action Lab. I'm John Zaccharis. I'm Senior Director of Data Architecture and Strategy within Action Lab, and I have Emily Ife, Jason Williams, and Ralph Andrade for they're going to help us out and go through the journey of what we're calling affectionately the golden thread. And it's meant, we're using the student journey as that analogy as we reimagine how we can service our analytical customers in a more customer focused with operational excellence, and apply some engineering patterns to that. So think of it in those terms, and we'll go on this journey together. So before we do, just a couple words around Action Lab. How many people were in Mike Sears and Liz Harrington's talk before lunch? Several of you, okay. Because I had a similar slide. But for those of you that are new, so Action Lab, we are part of EdPlus, and we're a research and data hub within EdPlus, and our focus is really on how do we get students to ASU, and oftentimes ASU online, because we are tightly work with EdPlus. But also once they're here, how do we make them successful? And so it's your persistence measures, but it's also beyond that. We also do efficacy studies on things that, experiments that we may do, like DSL and some of these other things, and we'll go into that in a second. Oops. So we have 4 teams within Action Lab. We have a marketing and behavioral analytics. This team is actually looking at Google Analytics. So as soon as a student or prospect student actually hits one of ASU's websites, we start to collect information on that student. So we know all the way from their curiosity, and then it goes into success. We can track them through enrollment, into persistence, making them successful, and ultimately graduation. Success Analytics is taking that further in that journey around the persistence and success. And then finally, there's scholarly research. So we have a team of PhDs, various multidisciplines that are working together to answer some of those questions of how can we do things better, what is effective, what works, what doesn't, with a lot of our different teams across EdPlus and ASU. And then finally, the data and architecture enrichment team, which is what we're representing here today, is supporting all those analytical and research teams. So some of the projects that we do within Action Lab, ASU Online, they're our main customer, take up a lot of our time, as far as that those are primarily where our dashboards and a lot of things that we were doing from analytical, and from a research standpoint, it's focused around online. But we also have some niche projects. We see here is our Starbucks partnership. So Starbucks, if you're a Starbucks barista, you can actually enroll ASU Online. They pay for your tuition. Well, there's a partnership there. There's a lot of analytics that goes back and forth, data sharing. We enable that. There's other corporate partners like Uber, like there's a list of InStride does a lot of those, manages those partners for us. And then we also have academic partners, and I'm gonna hit one of those later today, where it's other universities that we're actually helping them get their online system going and making them successful as well. There's other projects like efficacy. I mentioned Dreamscape Learn. So we did our research team did a 2-year RCT, a retroactive study on does Dreamscape Learn actually make a difference? And we it does. There's a whole research that we can, paper that we can actually point you to that if you're interested after this. And then finally, this one's really a different, is Study Hall. Study Hall is basically a YouTube site. We partnered with Hank Green, the Green brothers, and they did a lot of the content. But it's it's another channel for students to come to ASU, right? So they can, if they're not, if they don't get in the normal methods, that's another channel for them to come in. There's a lot of analytics, both behavioral, but also once they get here, how do they do? You know, did it make a difference?
So, a few years ago, our ecosystem probably looked familiar to many of you. It was a mix of legacy dashboards, manual ETL processes, duplicated logic, and inconsistent standards. It was a mess, basically. Every update risked breaking something downstream. We didn't know where dependencies were. Without transformation discipline or centralized ownership, maintenance consumed 80% of our staff time. That's all we spent our time doing, was just maintaining the workflows. Our turning point came when we reframed the problem, not as a tooling issue, but as an operational challenge. We needed a culture of transformation discipline built on standards, automation, and aligned with the ASU EDW as our single source of truth. So, to do that, our goal was simple. We wanted to move from firefighting to process flow. We defined success as operational excellence, characterized by reduced downtime, reusable code, and improved speed to insight. And we've gotten there by reducing the manual maintenance through automation, anchoring transformation in the ADW, applying engineering principles like CI/CD, testing, and versioning, and building reusable transformation patterns for scale. Every workflow now follows a simple pattern: sourced from the EDW, transformed with DBT, orchestrated with Airflow. And it's not about the tools, it's about the discipline, the visibility, and the consistency. The golden thread has become our North Star. It's the way we make the student journey visible. And we do that through trusted, well-orchestrated data. 90% of our data originates in the enterprise data warehouse, ensuring every model starts from a reliable, governed foundation. For non-EDW data, like research projects or partner data sets, we extend those through Redshift external tables on S3. And that keeps everything in the same architecture and under the same operational standards. Transformation is where our insights emerge, the place where data quality, structure, and business meaning converge. It's where our operational excellence truly takes shape. But we can't do it alone. We're part of a bigger ecosystem, and we rely on other teams and departments all working together to help us accomplish our data goals. In Action Lab, we're building out the pipelines and the code, but we have to partner with enterprise technology for source data from the EDW and for security, with our EdPlus data ops team for infrastructure config and tool integration, and with AWS and GCP to host our core services.
So with those objectives, one of the things we realized is most of the work we do is around transformation. And so it was, how can we actually, with those success criteria, look for a tooling that gives us that ability. And the other part was our team had really two skill, like from a programming standpoint, they weren't developers. They're SQL professionals and they had some Python experience. So that's where we started to look at DBT. DBT is all SQL. And it actually puts a wrapper around. We're going to go into more detail what that is. But the other key component to why we went this way is we needed to have a solution that bridged our AWS environment, which we have a data mart that we get from, and all the data, well, most of the data is from the data warehouse, but also we have a lot of data at GCP. All that behavioral and marketing analytics, that's all GCP and BigQuery. So how can we actually have a tool that you can use the same code and it doesn't care where the data actually lives? And that abstraction is where DBT really, it's one dialect of SQL. No matter what the database or underlying storage technology, it's the same. It does all that translation for you. So it really abstracts a lot of those architectural issues. And so, in sticking with the open source, we then also using Airflow for orchestration, which we'll go through in a bit as well. The other side benefit that we've discovered as part of this journey is DBT is actually has a whole semantic layer, semantic modeling language built into it. And so Alexis and Josh had a talk this morning. It fits right into what they were discussing too, where it is that language to actually have the semantic layer in a common way. DBT actually has open sourced their metric flow, which is really going to enable it in Tableau and Alteryx, OpenAI. They've all kind of are starting to adopt that semantic language, is what they announced a couple of weeks ago. So this is where we kind of the context. We're going to focus mostly on the data mart, so the AWS and coming from the data warehouse as we walk through some examples.
So the Medallion architecture is how we organize transformation for reliability. We've got the bronze layer, as you'll see here. It's our raw data ingestion. Like Emily mentioned, about 90% of the source is from the EDW, and in some cases we use S3. Silver layer is our transformation layer, where we do, more modeling for particular cases. The gold layer is the certified and trusted data. And then the analytics schema, that's where we have abstracted logical views off of that gold layer that power our Tableau dashboards and AI models. So the DBT model, DBT allows us to treat SQL as engineered code, and brings the Medallion architecture to reality. DBT is merely SQL and SQL tests. Every model is version controlled, tested, and documented. This ensures repeatability and trust. Okay, so this is an example of a DBT model, and the secret to DBT is purely in the SQL extension through Jinja, which allows for parameterization and references. As you'll see, the reference here is from an EDW table. This is the configuration file. So with this, we can expand the model to include contracts, data types, data quality checks, and lineage. This purports like a highly efficient transformation process, deeply integrated, again, with ASU EDW. So this is an example of what that configuration file built out for us in DBT docs. And as you'll see, the description there is what we saw on the previous screen. It lists the columns, details of the table, This is just an extension of that same screen where it tells you what this model is dependent upon, and it even shows the code that was used and the code that is compiled that DBT actually runs. With that, I'm going to pass it over to Ralph.
So we do use Apache Airflow for our orchestration. Quickly, Apache Airflow just ties our Medallion architecture together. How do we get our data from raw, bronze to silver, gold, and to analytics? Thanks to Apache Airflow. Uh, as you may know or have used Alteryx's scheduler, it's very limited in functionality. It's, hey, do this at this time, X amount of times, and that's all the flexibility you get with it. With Airflow, you can actually set dependencies on your orchestration. Um, it honestly gives us the best operational control we can get out of the box with an open source platform. How we work within Airflow, we have three components that we mostly use. Uh, Operators or tasks perform the work for you. Sensors are just a predefined a subclass of operators that are waiting for direction. Like, what do you want me to do? When do you want me to do it? Think of it like a air quality sensor. It goes off whenever the air is bad in a room. So think of that sensor in the same way. Uh, Triggers are like place operators in a holding pattern until you need them. This is the new method of working with operators versus sensors, because triggers only take up a worker for the duration of the task, while sensors stay on and take up workers throughout the task or till the task is completed. Here you see it also provides us a visualizations of our orchestration through DAGs, also called directed acyclic graphs. It helps us visualize the upstream and the downstream and everything in between. Over here in this example, this DAG is grabbing raw data in our bronze layer from SA student run. We run some transformations on it, and we graduated to a gold version. In this case, we're creating a gold student run model, and we are using a bronze D-person view to create that model. Just tells you overall not only how and when to perform a task, but it also ties it all together with your upstream and your downstream processes. And to give us visibility on what's going on with Airflow, we recently implemented CloudWatch. We're using the metadata that Airflow provides us and logs to empower this dashboard to tell us what's going on with our orchestration layer.
So with that, I want to walk through one of our use cases that we did. And this is with one of our academic partners, University of Tennessee in Knoxville. University of Tennessee is very similar demographic to Arizona in that region, but they don't have the reach that we do as far as getting to those communities that are more remote, and how do they actually get it. So they're looking to how can they actually get a jump start on their online programs. So they came to EdPlus, and we actually provide them some materials. They're cross-enrolled. One of the happy benefits that we actually came out of this is also University of Tennessee is one of the only universities has a nuclear engineering program. So our engineering students are actually able to cross-enroll and take courses at University of Tennessee. So it's a win-win kind of scenario. But in order to do that, we have enrollment data, we have grades going back and forth between the two institutions. And so part of that, we did have, I think it was over 6 different workflows that were going every which direction. Data was all over the place just because it grew organically over time. And so what we were able to do is really, as we took a look at those from a pattern perspective, we were able to do it into 2 different workflows in essence. One is get the data to us, and then one is get the, send whatever data UTK actually needs going back. So what we're showing here is Airflow will ingest the data. We have the data coming into an S3 bucket. So then that actually goes into our bronze. So that's the raw data. We have DBT models that are enriching that data, merging it with other data sets so that we can actually have reports and things coming back and being sent to University of Tennessee. And also, it also goes to other areas within ASU, such as admissions and the provost office and other locations that are actually other departments that need that data as well. So we're able to centrally to kind of control where that goes using Airflow as that mechanism. So for an overall, we've been doing this, it was about a year ago, a little over a year ago, that I reached out to Mike Sharkey and some of the other folks in ET of how can we actually, this is our idea, how can we go about this? And so it took a while for us to get going and some traction, but I mean, what we've done once we've gotten going, we've converted over or deprecated over 100 different workflows. Our operational standpoint is we have fewer incidents because we have more insight of where and what steps what's the order of execution. And so that was a lot of trial and error, but we were able to actually make sense of that spaghetti code that Emily showed on one of the first slides, of all those dependencies that if you just looked across, it was almost impossible for us to figure out where do you start. And even when we do, it's more, when there is a problem, it's more just restarting. You don't have to actually do a lot of root cause. The other big benefit is we were able to reduce some of the processing that is on our Redshift cluster by 50% through identifying some zombie jobs that are out there that nobody knew was running. They were just out there taking recycles, so we were able to actually decommission those. And we did find some queries that caused a lot of the spike in our resource utilization as well. So one of the principles that we're doing is modularization. So instead of having one massive CTD that rules all and does everything in one big step, we break it into pieces. Each piece is a DBT model or a piece of SQL that gets chained together, and we let Redshift take care of the optimization. And by doing that, when something does fail, we know exactly what step in that process failed. Instead, like when I'm sure we all had the one big SQL, the debugging in root cause is a big issue. So that has led to some of these improvements. Improved data trust. I think one of the themes we were talking about is using the data warehouse, using the enrichment tables. Those came about, a lot of those enrichment tables came about after our original jobs had been created. We have a lot of legacy tech debt that we're dealing with, and how do we actually get to those? By leveraging the new assets and the centralized assets, it's really improving the trust of the data, and we can, it's one source of truth. So that's a big lesson learned as well, which goes to my next slide, which is some of the lessons learned. Automate. If you have a workflow or something that you're doing, and this is regardless of tooling, it's nothing to do with DBT or it doesn't matter what tool. if you're doing a manual step every day, you should figure out a way that you can automate that. Whether it's AI, whether it's an agent, whether it's scripting, Python, there's a solution to figure that out. Version control, very important. If you don't have version control and you have an error, you can't go back. If you actually use version control processes, you can actually go back to where it was before, and you can manage change in a controlled way, which is fundamental for us to get control operationally of the environment. Trusted data, already said that, and finally modularity, which can't stress that enough. Break things into chunks, because we often think that if I can do this in one step, it's that much simpler to explain. Yes, from the outside, but you put so much complexity in it. What happens if it does fail? What happens 5 years from now when you moved on to some other position and your successor is actually taking that role? How are they going to figure that out? So that's the other lesson learned here. What's next? We're excited about trying to get integrated with open metadata. DBT actually has plugins so we're eager to really start testing that so we can get bi-directional. So a lot of the descriptions and things that we were showing, we should be able to actually ingest it from open metadata as our starting point, especially for those data warehouse objects, and then also be able to publish back. So I think it's going to be an interesting use case. Expansion of AI ML support. Mentioned the semantic layer. I kind of see how that rolls out, but there's a lot of interest in EdPlus, and I know across the university. How do we actually have a curated way of getting at data in a meaningful way? Federated collaboration, there's discussions. We're actually talking, I think right after this, we have a talk on Tableau hyperfiles that we've been working with Sam and the rest of the Tableau team, kind of co-authoring on some of that. And so as we come up with these, we're working closely with other groups to see how we can work together and take it to the next step. And then just a continued focus on the student journey is really see where that takes us next. So with that, I'll open up to questions. Questions we can, and we do have, depending on where the questions go, we can go into more detail. Yeah. So we already had a Redshift instance right next to the data warehouse, so that was already there. And so because everything we're doing is open source at the moment, it's really just the running of those resources. So we're hosting Airflow at AWS they have a managed workflow for Apache Airflow, MWAA. I know it rolls off the tongue, but it actually does a pretty good job. And so it's just a matter of, we pay for what we use with that. And DBT runs within Airflow's instance. So and all the software is open source. So there's an incremental cost from just an operational standpoint, but not from a software procurement. It was SQL. Well, it was SQL store procedures, Alteryx. I'm sure there was some other things in there too. But yeah. And it wasn't the other big thing we're trying to do is since we're kind of doing a redo, is be consistent and use consistent patterns. Which next talk, me and Andrew Dang are doing a patterns talk. So. Just a plug, but it's through those patterns that repeatable, so that we, if we know, we have, like, for instance, we have a template for Airflow. You just put in the name of the what DBT you want, or actually we're running Alteryx through Airflow now too. So you just put the Airflow or the Alteryx name of the job, and it will schedule it off so that we can actually coordinate through those triggers and sensors when is the best time for it to do, instead of having it be run at 3 o'clock p.m. no matter what. Well, that doesn't work if everything's delayed or just a little bit delayed. Sometimes we had things, piling up. So that was a way for us to kind of get control of, if something does go wrong, that's okay as long as nothing else subsequently kicks off. As soon as something else kicks off, it becomes a big mess. And that's where a lot of the time that we were able to save came from. Mike.
So someone who's never used DBT, can you explain how writing SQL in DBT is different from writing SQL in DBeaver or Notepad or
Yeah. Actually, let me. So this is just the SQL statement with, doing a with to where you're doing your first select from. And if you notice, there's this ref GSA student that actually is another model, another SQL statement that it's referencing. At runtime, DBT actually knows what that physical table is. And so a model represents a table. It can be materialized as a table, a view, materialized view. There's a few other. But at the end of the day, it's just normal SQL that you would write, in DBeaver, with the addition of what they call Jinja. And Jinja is you have those two curly brackets, and so it gives you the ability to do referencing, macros. There's some macro, so like you can do things like cumulative averages over different, some of the things that in SQL that it tends to be a little tricky to do. There's some out of the box macros, or you can create your own macros too. But that's where it allows you to do. But what it does is, now if something changed in that model, it automatically gets inherited subsequently. So it allows you to do it. And every model has a configuration. It doesn't need one, but we actually, best practice, we have a configuration file, which is a YAML file. So it's like an outline that you're doing doing the so student ID, what's the data type, what's the description. You can also, this is where you would put your tests. So if you want to say this is a not null, or if you want to say this column needs to be exactly the same as this other table over here, there's tests built in that you just put into your configuration. So it's the SQL, but then it gives you the ability to do so much more around that SQL.
SQL you're writing is no longer standard executable SQL. It's got Jinja hash, right? It's now DBT SQL.
Yeah, so here's the example. So this is the same statement we're looking at with the Jinja. And then when you compile, the first thing it does is compiles it. So it actually is aware of what your physical database was, and it knows it was Redshift. So it translates that DBT model to Redshift SQL. And so it actually does the full path of where does that table exist. Right. Any nuances on like functions and things you might have between platforms, it's aware of that too. So it does that translation for you. Josh. That's a great question. So we were looking at, repeating the question, how are we sensing data warehouse jobs? Initially, we were looking at timestamps, but that's not very efficient, and nor exactly the best method. So right now we are working with the TOPS team to actually Control M and has an Airflow plugin, so we can actually, they're installing that for us so that we can actually have bidirectional, so we can actually have a sensor off of a Control M job or have a Control M job that is aware of our Airflow jobs as well. So it kind of extends that whole platform. But yeah, no, that was a yeah. We just didn't. You don't want to. We were looking at timestamps originally, and just that evaluation and pinging. That's where you get a lot of overhead. Oh, right. So we wanted everything to be off of the underlying job. So that's once we get the plumbing hooked up on that, we want to actually look to make sure we have the right jobs and we're linked up, and so we have a sync there. But that right now we have that's the one weak point we still have is we estimate when it's safe to trigger things off. That's another good question. And so actually, I was at DBT at the conference. Was it 3 weeks now? 2 weeks, 3 weeks now. Seems like last week, but when they announced that, and so they spent a lot of time talking through Fivetran. The question was DBT Labs and Fivetran announced a merger, and DBT grew on open source as their kind of bread and butter, supporting the open source community, and Fivetran is a software company. And so one of the things that they actually both Tristan and George, the two CEOs, repeatedly came back to was really the strengths of both of those. Tristan, the CEO of DBT Labs, said that they were a consulting company that came up with this idea of DBT, and so open source made sense. And then they said, well, if you're doing open source, you need to have some kind of company to maintain it. So they kind of backed into the business side of it, whereas Fivetran started off, we're going to be a business, right? And so those two strengths actually in the investment, the Fivetran can put more investment into it. They both gave support to open source. They committed to DBT Core, which is what we're using, which is that language layer that is a translation, like they're even adopting Iceberg and DuckDB and some of these other physical file data lake type file types. So that they're committed to that, and they want, and they also announced the metric flow open source for the semantic layer. So in which a lot of partnerships, they want to be the provider in the middle and agnostic of where data lives, so they don't care what platform you're on, or what cloud you're on. And they also want to support all BI, all AI, right? So and they're getting a lot of traction because right now there isn't an open source standard that like there's a semantic layer initiative that's there's about 20 companies that have signed on for it. They didn't have a standard, and so that's where metric flow is being offered as that standard. And so it's encouraging from that viewpoint, and where they want to take it it seems to be a pretty good story. Mhm.
But I noticed that there was a fourth pillar that you guys do. How is that different from the gold?
Yeah, so in our medallion, typical medallion is bronze, silver, gold. We added an analytics, and the idea was bronze is your raw data. So and when I say raw, it's however it is when you first see it. So in the case of like our data warehouse tables, it's that however the data warehouse team presents it, that's our bronze. Because if something's wrong, it's look to Josh, what's going on, or we need to change something, right? Silver is where our team actually touches it. So if we have to tweak something or merge it, silver is our transformation, and then gold is that we've put some tests, and some of it could be from a business end user. What are those tests? What's that certification? That's useful, but from like when you're starting to do like BI cubes or in the semantic layer, your dimensional modeling and things like that, that's what we envision that analytics space being. And most of those are just views off of gold. So everything's going through each one of those layers. We're not going, analytics to bronze directly. We want everything to go through every layer so that you get all, because each layer is incrementally adds value. That answer?
So, do you create the data models in the gold layer or in the analytics division at the end? Like models like transfer and
Oh, yeah. So we do that in the analytics layer. And actually, that's where we're looking at semantic layer to be because what a semantic layer, at least in the metric flow DBT language, it's, if you think of Tableau as you have dimensions, you have facts, you have measure, like aggregation measures. That's within that context of that workbook. What metric flow is, that semantic, it gives you universally, so it's aware of everything else that's out there. So you can create one semantic model that rules them all, if you will, right? So that's where I think that one morphs, I think, more into more of a semantic model rather than a DBT model. But for now, since we don't have we're not quite there with a semantic model, that it's just other tables. Yeah. Uh-huh. So the example, like SA student was one that we used. Right now, it's almost a select star going all the way through. So it's the base, and we'll continue to have, the thought is we'll have a SA student version, but we still have it go through it. So it gives us a starting point. For instance, we had a version of student called EP student that we went through, and we sourced it from five, six other tables within the, PeopleSoft and other places. It doesn't exactly match what SA student is, but we think we can get by with SA student. But let's say there's a few columns that we do need. We'll create a silver off of that to merge the two, and then it becomes its own thing. But we always want to have what we brought in, be able to, because one, I mean, if there's two departments within the university and they happen to be in the same meeting, we want to be at least aware of, if the provost has a different calculation than we do, that's okay, but we want to make sure both of us understand we have a difference, right, so we can explain it.
You could add those columns in your model, or you could put in a request to have them added as a student.
That's just true. And actually that's the way we see that is we would do that, but it allows us to fast track and be able to do something in the interim. So as we're waiting for it to actually come through, we can actually have it available, make use of it in a pressing project that we have, then it will be available. So that's the life cycle that I envision that we have, is we'll develop something quick, and then hand it off to see how we can get it in the base model itself, and then deprecate the one we had.
So I'm just looking here, so I might not understand all the context. But the question I have is Medallion architecture. It has a lot of pros, but it's also really difficult to implement, and sometimes it might seem as an, for lack of better word, an overkill. So the question I want to ask you is Medallion architecture the way forward, or are we getting to the use cases where we think probably a traditional approach would limit?
I think it depends on your mission. So if your context is just whatever application you're looking at, yeah, it's not the most efficient way to do it. But in our case, one of the problems we were facing with is we would have bad data get into those final table, actually into our dashboards, right? And so, and then it's one of our users that actually calls us up and says, you know, your dashboard has the wrong data, or actually we had data disappearing, right? The table just gone. We want to catch those things before it gets to that point. So that's where our goal actually, we see the value. It's not that we're trying to check everything, but we want to make sure if there is a problem, we catch it before we actually display it on a dashboard. So that's why we, you know, we're willing to take on it being a little less efficient in order to have more of a quality aspect. So it all depends on what your scope of what the problem you're trying to solve. So you know, if it's not that broad, yeah, you wouldn't require that. But we had you know, hundreds of workflows, hundreds of dashboards that we're trying to, you know, manage every day, that we need that consistency. Okay, I think we're just about at time. Yeah, well, that's Josh. Why don't we just hang out?
You mentioned you can or are running Ultrix in DBT.
So we're actually kicking it off we're using Airflow as a scheduler.
So what are you still doing in Ultrix? Is this legacy jobs? Is there
Yes.
functionality in Ultrix that you can't replicate in DBT?
No, so this is legacy that we're still working on trying to sunset. Yeah, so our goal is, that's the next goal. Now we have the foundation, we're going to be making an effort. We've done a few. We want to kind of fast track and try to see how we can get more into DBT. But we have proven that even like some of the complex Ultrix macros and things all can be replicated within DBT. So
So thinking from like an advanced analytics perspective, you can run Python scripts in DBT.
Mhm.
Can you just like throw a Jupyter notebook in the middle of a DBT workflow and have it process?
so a model can be a Python object. So it treats, if you think about a SQL statement, it has output, it has an output. So as long as you have code that does an output, takes an input and doesn't even have to take an input. As long as it has an output, you can have that be a model. So there's probably no reason other than performance. I mean, but yes, you're able to actually have that model be Python. And we also have, for some of our store procedures, we're just executing that store procedure code where we need to, so that becomes a model then. So in the short term, long term, because of all the documentation and testing, we want to convert it. Well, thank you so much, and enjoy the rest of your conference.